Lesson number 89 today is about value problems. And our first question says, bus fares are $30 for first class and $25 for tourist class. If a bus had 52 passengers who paid a total of $1,360, how many first class passengers were on the bus? Now when we have value problems like this, we have two pieces. The first piece is about money. How much the first class tickets cost, how much the tourist tickets cost, and how much the total is. And then the second part is about the number of passengers that we had on the bus. So in order to do this problem, we need two equations. The first one will deal with money. So let's say the number of first class, n sub f, okay? And it's $30 per that. $30 times the number of first class tickets, plus $25 times the number of tourist class tickets, so that's the number n sub t for number of tourist class, is going to equal a grand total of $1,360. Here's our first equation. Now our second equation is going to be all about how many passengers there were. And we know we had a total of 52 passengers. And they could only be first class and tourist class passengers. So the number of first class plus the number of tourist class will equal a grand total of 52. So when we take this, we can now go ahead and solve the equation. Let's solve this equation using elimination. Now this is a big space that we've taken up on our whole screen, so I'm going to shrink this down. If we take this thing and we shrink it down, we can then copy it, and let's paste it, and it pastes right on top, and we'll take those individual pieces. Whoops, that didn't work so well. Here's one piece, and then the other piece. We've got our n sub f plus n sub t equals 52. And we're going to reset it up over here. Now, we'll take this whole thing and try to make it a little bit bigger. Now, in order to do this problem, what we need to do is we need to eliminate n sub f or n sub t. Let's eliminate n sub f because it's first. So in order to do that, let's multiply our second equation by negative 30. And then when we do that, we can find our answer. Because when we multiply that, we're going to get our first piece, which is 30 times n sub f plus 25 times n sub t equals 1,360. And our second part is now going to be negative 30 n sub f minus 30 n sub t equals negative 30 times 52. Well, let's figure out what that is. Negative 30 times 52. Well, 2 times 0 is 0, and 2 times 3 is 6. We've got 5 times 0 is 0, and 3 times 5 is 15. So we must get 1560. So it's going to equal 1,560. And now we can go ahead. And we can eliminate n sub f by adding the equations together. We've got 25 plus negative 30. Well, that's going to be equal to negative 5 n sub t will equal, and we have 1,360 plus 1,560. That must equal 2,920. And now we can find our answer for n sub t by saying 2,920 divided by negative 5. Now if we go ahead and do that, you should be thinking, whoa, we've got a weird answer. We shouldn't have a negative answer, we should have a positive answer. So in order to get that positive answer, we need to look back and see we were supposed to multiply negative 30 times 52, which would equal negative 1560, which would give us negative 1560 here. And then when we add them together, we don't get 2,920, we're going to get something much smaller, and it's going to be a negative number. 1,360 minus 1560 is going to give us negative 200. And now our answer will make sense. N sub t, the number of tourist class passengers, is going to be a positive number. We better have a positive number of tourist class passengers. We can't have a negative number. 200 divided by 5, that must be equal to 40. So n sub t equals 40. That's good, because n sub f plus n sub t equals 52. So if n sub t equals 40, what must n sub f equal? Well, n sub f must equal 12, because 12 plus 40 equals 52. So n sub f, that's going to equal 12. And now we've got our final answers. Remember when you do these problems to solve for both pieces of the problem, n sub f and n sub t. We've got one more today. A dress shop sold less expensive dresses for $20 each and more expensive ones for $45 each. The shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive dresses. How many of each kind did they sell in all? So in this one, instead of using a subscripted variables, let's say the less expensive dresses are X. And then we're going to say the more expensive ones, the more expensive dresses, we'll call them Y. So the less expensive dresses are $20 each. So 20 times X plus the more expensive one will be 45 times Y will equal $1,375. This is all in dollars. Then it said the shop took in this much money, $1,375, and sold 20 more of the less expensive dresses than the more expensive dresses. So if they sold 20 more of the less expensive dresses, it means we must take the expensive dresses, which is Y, and we must add 20 on to Y in order to get to X, because it said they sold 20 more of the less expensive dresses than the more expensive dresses. So the problem will have the more expensive plus 20 equals the less expensive. Now, instead of using X and Y here, we could have used subscripted variables. We could have said something like this. We could have said the number of less expensive, number of L, and we could have said the number of more expensive is the number of more expensive dresses. And sometimes that's easier to keep track of. But you can solve the problem either way. So let's do it the way we've begun. Now this problem looks like it's setting up very well for substitution, because we know what X equals. It's Y plus 20. So let's substitute that into our first equation. We're going to get 20 times Y plus 20, because we substitute Y plus 20 for X, plus 45Y equals 1375. So we'll use the distributive property, and we're going to get 20Y plus 400 plus 45Y equals 1375. Now we need to put our Y's together. So we have 20 Y's, 45 Y's, that must equal 65 Y's. Then we're going to subtract 400 at the same time. And if we subtract 400 from 1375, well, we must be left with 1375 minus 400. Can you do this one in your head? Well, 1375 minus 400, that must give us 975. So we've got 65Y is equal to 975. Then we can go ahead and divide both sides by 65 to find our answer. Well, 975 divided by 65, let's see what we get. We'll erase some of our work on the side. 65 goes into 97 one time. Whoops, we need the pen. That's 65, and we subtract that to get 32, and we bring down our 5. Well, how many times does 65 go into 325? Let's try 5. And 5 would make sense because 60 times 5 is 300, and 5 times 5 is 25. So let's just multiply it out, 65 times 5, to see what we get. 5 times 5 is 25, carry the 2. 5 times 6 is 30, plus 2 more is 325. Very good. So we've got an answer of 15. Y must be equal to 15. So Y is 15, so that's the number of more expensive dresses. They were $45 each. Now Y plus 20 equals X. So 15 plus 20 is going to equal the number of less expensive dresses, and that's equal to 35. So now when we write our answers out for this problem, we need to say 15, and 15 is Y. That's 15 expensive dresses and 35 less expensive. And we should write dresses here as well. And then we've got our final answers. We could go ahead and box both of those and move on. Remember, you could have used subscripted variables. It might have made it so you won't have to look back at your original problem to see what x equaled and y equaled. But if you use x and y, be sure you know which one is x, like we marked up here. And be sure you know which one is y, just like we marked up here. And then we work through our problem that way. Our lesson practice will be on page 372. Make sure you got your notes complete, and I'll see you during our next class.